Καλησπέρα σε όλους. Hello everyone. Καλώς ήρθατε στο Nvidia Solutions for Higher Education και Research webinar που διοργανώνουμε η CosmosBusinessSystems μαζί με την Nvidia. Θα ξεκινήσει την ομιλία μας ο κύριος Πάνος Δελάκος, Manager IT Infrastructure της Ελλάδος και της Κύπρου για την CosmosBusinessSystems. Ευχαριστούμε πολύ. Μπορείτε κατά τη διάρκεια του webinar, καθώς και στο τέλος, να μας κάνετε ερωτήσεις στο Q&A κουτάκι, ώστε να απαντηθούν στο τέλος της παρουσίασης. Κύριε Παναγιδελάκο, μπορείτε να ξεκινήσετε.
Έλενα, σε ευχαριστώ πολύ. Καλησπέρα και από μένα. Ονομάζομαι Παναγιώτης Δελάκος. Είμαι ο IT Infrastructure Manager της CosmosBusinessSystems για την Ελλάδα και την Κύπρο και είμαι ο υπεύθυνος διαχείρισης της συνεργασίας της εταιρείας μας με την Nvidia. Θα ξεκινήσει η παρουσίαση με ένα πολύ σύντομο βίντεο και επανέρχομαι. Ο όμιλος εταιριών της Cosmos, όπως πολλοί από εσάς ήδη γνωρίζετε, αποτελείται από την CosmosBusinessSystems, η οποία είναι και η μητρική εταιρεία του ομίλου, η οποία διαθέτει υποκατάστημα και στην Θεσσαλονίκη. Η θυγατρική μας στην Κύπρο, η CBS IT, και το software arm του ομίλου, η οποία είναι η Cosmos Consulting. Η εταιρεία μας ιδρύθηκε πριν από 30 χρόνια περίπου. Συνεργαζόμαστε επιτυχώς για όλα αυτά τα χρόνια με 35 εξειδικευμένους κατασκευαστές και συνεργάτες στο εξωτερικό. Ο κύκλος εργασιών μας κυμάνθηκε το 2009 στα 32 εκατομμύρια και παρά τις δύσκολες συνθήκες τις οποίες βιώνουμε, η πρόβλεψή μας για το 2020 είναι περί τα 35 εκατομμύρια ευρώ. Το εργατικό μας δυναμικό ανέρχεται στα 190 άτομα, με πάνω από 1.000 πιστοποιήσεις από όλους τους κατασκευαστές, τόσο σε τεχνικούς όσο και σε προσωπικό πωλήσεων. Με την Nvidia ξεκινήσαμε τη συνεργασία μας προδιετίας περίπου το 2018. Διαθέτουμε όλες τις απαραίτητες πιστοποιήσεις τόσο στο κομμάτι του sales, του pre-sales, αλλά και στο τεχνικό κομμάτι που αφορούν την εγκατάσταση και υποστήριξη των εν λόγω συστημάτων. Τα εκπαιδευτικά ιδρύματα καθ' όλα τα 37 χρόνια ύπαρξής μας αποτελούν έναν από τους βασικούς συνεργάτες μας. Έχουμε συνεργαστεί σχεδόν με το σύνολο των εκπαιδευτικών ιδρυμάτων στην Ελλάδα. Ενδεικτικά μπορείτε να δείτε μερικά από αυτά. Η συνεργασία μας ξεκινάει από την προμήθεια τεχνολογικού εξοπλισμού, επεκτείνεται στην εγκατάσταση και προμήθεια υπηρεσιών τηλεφωνίας, εργαστηριακού εξοπλισμού, εκπαιδευτικών πακέτων διδασκαλίας και κάτι το οποίο είναι πιο σχετικό με τη σημερινή μας παρουσίαση. Εξειδικευόμαστε στην προμήθεια και εγκατάσταση HPC συστημάτων και VDI. Ενδεικτικά να σας πω ότι 8 στα 10 HPC έργα τα οποία έχουν υλοποιηθεί στον ακαδημαϊκό χώρο στην Ελλάδα και στην Κύπρο τα έχουμε υλοποιήσει εμείς, προσφέροντας λύσεις διαφόρων κατασκευαστών. Συνεχίζουμε και βλέπετε ενδεικτικούς πελάτες όπως το Πανεπιστήμιο Κρήτης, το Πανεπιστήμιο Αιγαίου, το Πανεπιστήμιο Δυτικής Μακεδονίας, όπως επίσης και κεντρικά με το Υπουργείο Παιδείας, έχοντας υλοποιήσει πλήθος έργων για τα σχολεία. Θα ήθελα λίγο να σταθώ στην δημιουργία του Εθνικού Υπολογιστικού Συστήματος Υψηλών Επιδόσεων, το HPC της GRNet, το οποίο έχουμε υλοποιήσει σε 2 φάσεις και βρίσκεται σε παραγωγική λειτουργία τα τελευταία χρόνια. Όπως επίσης και το υπερυπολογιστικό σύστημα, το National Computing στην Κύπρο, μέσω του The Cyprus Institute, με storage capacity που ξεπερνά τα 1,8 petabytes. Οπότε θεωρούμε τον εαυτό μας αρκετά εξειδικευμένους στο κομμάτι του HPC. Η τεχνητή νοημοσύνη εκτιμάται, σύμφωνα με πρόσφατες έρευνες, ότι θα αναπτυχθεί με ρυθμό που θα αγγίζει περίπου το 50% στα επόμενα 2 με 3 χρόνια. Στην ανάπτυξη αυτή, η τριτοβάθμια εκπαίδευση θα βρίσκεται στο προσκήνιο των εξελίξεων αυτών, καταρτίζοντας τους νέους και καινοτόμους επιστήμονες στο κομμάτι του accelerated computing και του data science. Ταυτόχρονα, τα εκπαιδευτικά ιδρύματα και τα ερευνητικά κέντρα θα πρέπει για να ανταποκριθούν στη ζήτηση αυτή για πιο ευέλικτες και προσβάσιμες εκπαιδευτικές επιλογές, θα πρέπει να διερευνήσουν νέους τρόπους εκπαίδευσης. Από το on-premise έως το cloud, η Nvidia και οι λύσεις της μας παρέχουν τα εργαλεία που μπορούν να προωθήσουν την καινοτομία ανά πάσα στιγμή και από οποιοδήποτε τοποθεσία. Αυτή ήταν μια πολύ σύντομη εισαγωγή για εμάς και στο σημείο αυτό θα ήθελα να δώσω το λόγο στους συναδέλφους από την Nvidia. I will have to switch now into English. So this is where my introduction ends. And Matthew, you can have the digital floor now.
Okay. So let me share the screen. Can you see the screen right now?
Yes, I can see.
All good? Okay, so we're gonna switch in English. Sorry for that, but Panos, I hear Nvidia, HPC, Nvidia into your intro, so I think we're on the right track to to begin. So thanks for having us for this webinar. Very happy to talk to all of you. So my name is Mathieu Gastelio. I'm the partner business manager, so managing the relationship with Cosmos, and with me are Clemens, with our sales account manager dedicated to HR solutions, and Carlo Nardon, our senior solution architect. So I'm going to do a quick intro, not too long, because we have a lot to cover. Then Clemens will dig into our solution dedicated for education customer, and Carlo will go into a technical deep dive. We have a lot of announcements, very rich news recently with the GTC and supercomputing. So he will go through that. So just as the quick intro on Nvidia, if some of you don't know Nvidia, I guess not, but we never know. So Nvidia was founded in 1993 and pioneer what we call GPU computing. Okay, so this is this technology, that innovation that powers every industry, and maybe you don't know it. So to give you a few examples, so we power Google, we power Facebook, all the major cloud service providers today. We are helping car manufacturers to develop autonomous vehicles. We power as well the world's fastest supercomputer, which is called Summit. And I think Carlo will mention the top 500 into his presentation lately. We produce every single film winning Oscars on visual effect the last 10 years. And of course, probably many of you knows us for powering the gaming industry. This is where we come from, where we started with our invention of the GPU. So we are into the accelerated computing business for a quarter century now. Okay, so that goes back to the founding of Nvidia in 1999 when we invented the GPU, which became a programmable accelerator, and we have been innovating on it ever since. Okay, so on the left, you can see that it has allowed us to make what we call X-factor speed up, okay, which is much faster than Moore's law that you probably have heard of. And we continue on that pace, not only on GPU, but also adding DPUs to the mix right now. And you will see when we go through our new architecture, Ampere, and the latest announcement that the pace of innovation of speeding up, this X factor is very important to us. So we are an acceleration company, not only for graphics, but also for AI, for HPC, for data analytics, as well as rendering and neural networking. So, but in addition to that, so this is the second square on this graph. We are also, and this is very important, we are also a full stack company, okay? Because what is highly and super important for us is about how we do what we do is that not only do we bring great hardware on the table, but we bring phenomenal software. And as a matter of fact, we have today twice more software engineers than we have hardware engineers at Nvidia. And that allows us to deliver this full stack platform. And so the conversation must not be limited only about the quality of the hardware, but really talk about this full stack and the great ecosystem to support the accelerator. Okay, so we continue to innovate. Next square is that now we have expanded how we innovate to the data center scale. So we design things like Selene, which is our own supercomputer, the Nvidia supercomputer, that allow us to really think about the full design of the data center and how to build great acceleration at data center scale, which is becoming right now the new computing unit. Okay, data center, not only GPU. And the last thing on the right is that we talk about one architecture, okay? Which so basically we have our GPU, we have added DPU to the mix right now, but we are using our Cuda software architecture that allows us to deliver innovation that can run on a large variety of places. So whether it's data center, workstation, edge, or so once you have developed on our software or CUDA, you can deploy anywhere. So this is very important. So as I mentioned in the previous slide, we do see ourselves as a data center platform company, and that's really the way you need to understand about the work that we do. So we do not just accelerate application, we accelerate the entire workflow, and we do that across a wide variety of domains. So you see on this slide 4 of the big one listed. So data analytics, simulation, artificial AI, visualization. And as an example, in the case of HPC that you find under simulation here, we support over 700 applications and we accelerate them. So that's the work we have been doing since the inception of CUDA 10 years ago. And as other examples, so in the case of AI, we accelerate all the measure frameworks, PyTorch, TensorFlow, to name a few, both on training and inference. And in terms of where we accelerate them, we do it once again in a wide variety of form factor, whether it's workstation, data center, edge, supercomputer, and as in the cloud as well, as Panos mentioned. Okay. Oops. Next one. Okay, so just to once again to give a few words about our ecosystem. So we continue to expand our ecosystem to various support, whether it's software stack in our ecosystem of developer, and we do what we show here is that We have delivered last year over 80 new SDKs. We have now more than 2 million developers developing on our platform. We have had 6 million CUDA downloads only this year, and 1,800 applications, GPU accelerated. We have a program called Inception, where we work with startups. I think we have more than 6,500 right now. So you see that this notion of what it takes to be successful is to deliver on the whole ecosystem. Okay. So we talk, I talked several times about platforms. So if we want to elaborate quickly on it, so I think I know this slide is not really easy to read, but it kind of describes all the things that we do to make the platform happen. So you can see on the software and the two bottom layers of our stack here. But what is important to understand is how many other components there are in this stack to make it successful, whether it's application frameworks, SDKs, library, NGST, or cloud repository, certification process for servers. So all those elements are very important, and you need to have the full picture to understand that to develop any solution for yourself, it's not going to be only the hardware part, but it's much more. Okay, so I think we will dig into it with Carlo's presentation. So I wanted to give you this quick overview of NVIDIA as a platform, and I'm going to stop here and to pass it over to Clemence to go on the specific higher education market solution.
Yes, thank you, Mathieu.
Okay.
Perfect. So thank you very much for joining us today. As Mathieu said, I am part of the higher education team here at NVIDIA. And I think it's a really exciting time to be part of this community and this ecosystem. We really believe at NVIDIA that we have the solutions and tools to help you both navigate through today, but also really prepare you for the future. So firstly, I can't change the slides. There we go. Okay, sorry. So while this is an exciting time to be part of the ecosystem, there are some challenges that may have an impact on the efforts that you're putting forth that really do need to be considered. So first of all, the battle for funding. More and more researchers are competing for level funding dollars. IT budgets are not growing to match technology infrastructure demands. So these are just some examples of that. Secondly, attracting best talent. It's funds and lab equipment that's a deciding factor for faculty and students. So we need to consider that as well. Changing curricula, the demand for skilled data scientists and AI expertise requires students to hit the ground running after graduation. Complexity, so the research problems, the student projects that you're doing, they're more complex than ever. The data sets and compute requirements are growing exponentially, which is where we're coming. And then finally, the in-person and remote learning, especially at this time, this whole year. So distance learning at scale introduces a new set of challenges for educators, researchers, students, and IT staff. Now, just to touch on, so the demand for AI, as Mathieu touched upon already, it's growing very fast. So I like to say the genie is out of the bottle when it comes to AI technologies. And there are multiple signs that show the growth and the acceleration. So first is if we look at the number of papers published with AI. So if you see on the graph on the left, while the dark green line is showing the AI specific papers nearly doubling every year, the other important factor, which is a light green line, is the use of AI as part of HPC or traditional science research. And that's also seeing nearly a doubling. And so there's been a number of papers year after year for the last 8 years that have been published. And data science is impacting almost every industry, as we have touched upon, but deep learning is also playing a significant role in these industries with things like natural language processing, and understanding, just a couple of examples. And finally, both the number of networks and the size of networks have exploded quickly with large networks like things like BERT or GPT. And so this continually increases the need for more and more computational power to be able to leverage these. So in terms of higher education and research and how to build AI leadership and to address the challenges I have put forward. So we at Nvidia, we talk to universities all over the world, and the 4 areas here really represent where we see the leaders excelling. So first of all, we're all in this together. Think funding agencies, universities, faculty, researchers, even industry partners, where the way that things have been done in the past are not going to address the leadership needs of today, particularly for universities. So first of all, universities need to be thinking big about the current problems and affecting the region or the nation even. And they need to be prepared to find ways to fund at this level. So I will touch upon this later, but for example, the University of Florida, it has launched an initiative to holistically transform the university. Plus, universities need to understand that what investments will be needed to maintain their top talent, as I've mentioned before. This is, the top talent, but also the top infrastructure to do the research. And because of that, university will increase their funding, and we've seen multiple examples of that over the last few years. Finally, the universities need also to find ways to accelerate building the AI expertise and skills at the industry needs. So that's critical. So how do you make sure that you're well connected into the needs that you're building for? So at Nvidia, again, this slide is a bit busy, but in terms of the solutions, specifically the platform we have for our education, we have a track record and a history of investing and partnering with universities over the last several years. So in addition to the large developer focus that we have multiple higher education programs to support and accelerate a university in their accelerated computing journey, including deployment of best practices based on workloads and university needs. So you can see as well the teaching kits, that's part of our Deep Learning Institute, which is a hands-on learning tool with multiple options for the higher education community, and that's what we use for in-person workshops or courses and self-paced learning. However, at the moment, it is all virtual. NVIDIA products and solutions can be accessed in multiple different ways, from public clouds to university data centers or individual workstation or laptops. So we help to get the researcher in the facilities and the students access to through different environments. Now, in terms of our GPU computing platform, hardware and software, we offer a wide array. It's a full platform, and Carla will go into more detail around the specifics later on. But before doing that, I wanted to tell you a bit about some customer success stories we've had for accelerated computing. So at KIT, which is the Karlsruhe Institute of Technology. They is the first location in Europe to put the Bjx A100 system into operation, which you'll hear a bit about more later with our newer Ampere architecture GPUs. So the systems were acquired from the funds from the Helmholtz AI Computing Resources Initiative, and it's closely linked to the AI platform there. The new system allows researchers to optimize their applications for KIT's future supercomputer called Horeca, and it will also use NVIDIA A100 GPUs, but 740 of them instead of just 8 per DGX system. And once it's fully operational in maybe next summer, it'd be expected to be one of the 10 fastest supercomputers in Europe, which is very exciting. Now, I have mentioned University of Florida before, so just to touch upon that, the University of Florida announced a $70 million public-private partnership with NVIDIA that will provide students, faculty, and researchers access to the most powerful AI training tools. The system build includes 140 DGX A100s. That's 1,120 NVIDIA Tensor Core GPUs and 700 petaflops performance. AI performance. So this partnership also aims to create a framework to ensure equitable access to bringing AI to students and faculty from across campus and across the state of Florida. It will give faculty and students within and beyond the University of Florida the tools to apply AI across a multitude of areas to improve lives, bolster industry, and create economic growth across the state. Now, on a smaller scale, just because we don't all have 70 million lying around, so the Martineau Center for Biomedical Imaging, they were working on MRIs, which, as you know, can take up to 2 hours, and subsample data speed scanning time, but contributes to an accurate image reconstruction. So the researchers from Harvard University and the center, they're using deep learning to speed up image reconstruction without compromising accuracy. Their AI framework is powered by DGX-1, which is the last generation of DGX, and now we have the newer DGX A100, which is more powerful. But nevertheless, it still reconstructs images directly from sensor data, and that's 100 times faster with 5 times higher accuracy than previously. Now, in terms of the software, because I've been just talking about the hardware, so NGC, which Carla will talk about a bit more, is our repository of containers. It is supporting the HPC needs of researchers from over 50 university departments at the University of Clemson. And now the installations take minutes versus half a day or longer to support the HPC administration. So that's another example of how efficient just software can be. And finally, in terms of virtual reality, virtual worlds, autonomous driving, University of Michigan is using some of our platform as well to just bring autonomous driving to a better scale in a virtual world, and having using less resources, but delivering the same results. So before we get on to Carlos' portion, I just wanted to briefly touch upon remote work, which I'm sure everyone is doing at the moment. And I just wanted to let you know that we do have some solutions for you. So we have some trends in education that we've seen from remote learning. So that's anywhere access. So students are accessing all their applications from any device, even on low-cost Chromebooks and tablets. New ways of learning. We have an interactive digital content. So interactive digital content provide highly visual and hands-on learning experiences, increasing student engagements. Thirdly, virtual labs augment research and classroom learning, increasing student retention while lowering infrastructure costs. And thirdly, digital lectures move learning from the confines of the traditional lecture hall. More than 1 in 4 students now take at least one distance education course in normal times. Right now it's 100%. So the benefits of Nvidia Virtual GPU, which I will touch upon just which GPUs you can use later on. So to overcome the challenges of traditional VDI, so it offers enhanced mobility and flexibility, so access to any application on any device, and improved collaboration across students, faculty, and peers. So again, that's answering to the trends that we see. It supports interactive learning environments, enabling new ways of learning, including having use of multimedia and video to supplement classroom learning. It increases manageability and scalability by centralizing data and applications at the data center and cost-effectively managing large-scale visualization deployments. And finally, it increases student retention with real-time virtual labs and expands accessibility with online programs. So here you can see the different GPUs for different workloads. We have 4 different types of licenses that you would need to get to virtualize your GPU. So we have vApps, which is virtualizing the applications only. VPC, which is virtualizing the desktops. And if you're only using, for example, Office or kind of low graphical performance applications. And then we have VDWS, which when you are virtualizing the desktop, but with also using a lot of 3D applications like AutoCAD, etc. And then VCS, which is when you want to virtualize the GPU and to do AI and compute. Now, for VApps, we do recommend M10. Which is great for streaming videos, for example, and for office productivity. The T4 is great for VPC or VDWS because it, it has enterprise acceleration, graphics, analytics, inferencing built into it. For more performant, high-end graphical applications like complex CAD models or seismic exploration, 3D imaging, then the RTX 6000 and 8000. Now, we do have some newer GPUs that are coming out that Carlo will talk about that will be enabled for VDI. And so this, if you are more interested in this as well, just come to me and I can explain to you what will be in the future. And then finally, the V100S is for VCS. So, and you can see, depending on what you're doing and which applications you're using, we recommend for architecture, engineering, and design students, we recommend VWS because you do a lot of CAD or 3D animation software. You use that a lot. For just general student body, we recommend VPC. Just to general purpose for Windows 10 productivity, and then for research to access GPUs cost effectively, we recommend a VCS. So, so I'm gonna let Carlo talk now. So thank you so much for listening. And if you have any questions, you can come to me directly.
Okay, thanks, Clemens. Thanks, Mathieu. Thanks to our friends at Cosmos, and thank you, every one of you, to coming up with this remotely or virtually to this presentation. So I'll have lots of slides, maybe too many, so I'll try to be a little bit quick. So Mathieu, probably you have the control, right? Yeah. Thank you. So let's skip. So let's just have a quick look at the agenda. We have several things I'd like to cover. Besides the introduction, which was already done by Mathieu, basically, we will talk about the role of the really growing role of NVIDIA acceleration for HPC in general, scientific computing, with a touch on life sciences, which is so important nowadays with the pandemic ongoing. Then I'll go to some explaining some details of our latest announcements in terms of GPU architecture, the new Ampere GPU architecture, the A100, which is our new flagship GPU product, with other things related to architecture, including NVLink and so on. Then I'll explain our Bjx Family of products, which is NVIDIA branded. It's a nice way to have kind of an appliance for AI and HPC, which can be the building block for larger clusters, like we call them Bjx Pod. And finally, I'll touch upon some of the software tools in our software stack, mostly related to AI, including, of course, our NGC repository, where you will find basically everything. So next slide, please. So this was already explained by Mathieu, so I will go to the next one. Thanks. And again, this is just to give you a feeling regarding how really rich is our environment to build up applications and build up a modern, let's say, infrastructure, including, for example, VMware, OpenShift, OpenStack, and so on, or things like, all the word about, Kubernetes kind of infrastructure, containers, of course, which is nowadays or very popular, not only enterprise, but also in HPC, maybe Singularity containers or Docker, as well as all the, the software we have on the more on the research and education which was already explained. So maybe let's go to the next slide. So I want to touch upon something which is interesting because it's an important point here. So in not only compute in the modern world of supercomputing, highest performance computing, and also enterprise computing, it's very important to the aspect of data I/O and data traffic. So that computing is not enough, the accelerating computing, but also accelerating the network. And as you know, we acquired quite recently we acquired Mellanox to improve our efforts around this. So we have an umbrella term, we call that Magnum Io, in order to emphasize our multiple ways in order to improve and accelerate the I/O, as I said. So the storage, for example, GPU direct storage is an ongoing effort. It's still in preview, in early access, but it's ongoing, and there are already some storage vendors supporting that. On the network side, we have a GPU Direct, for example, which works very well with the Mellanox network cards, and NCCL, which is our library to do let's say multi-node, multi-GPU, multi-node computations, and so on. So Sharp for in-network computing. Next slide, please. A couple of examples here are depicted. So GPU Direct RDMA is on top. It's a way to have basically node-to-node direct traffic data without touching the CPU. So the GPU talk each other directly. And Sharp is an in-network computing capability on Nvidia Mellanox InfiniBand switches, so that basically all-to-all reduce computations, or this sort of things are done on the switch itself rather than on the CPU. So it's a kind of an offloading of computation on the network, and this improves a lot the scalability. Next one, please. So HPC. Next one. So the new world on HPC is expanding. As I mentioned, it's not just supercomputing, but it's a network. It's the storage with extreme I/O, and it's also lots of sensors. So you may have in your scientific research project, you may have petabytes of data, or terabytes per second kind of data traffic from the sensors. Think about CERN. Think about the next one, please. The SKA array of radio telescopes, for example, and so on. So as a consequence, we really have now a kind of a mindset leadership on supercomputing, including the fact, of course, that now AI is growing in importance in the scientific computing itself and the HPC. So so we invested a lot on that, and improving the full stack hardware and software gave a really impressive achievements, like 11x performance speed up in about 5 years, growing in the architecture and also in the software. For a bunch of HPC applications, we have now NVIDIA is #1 in MLF-Perf, which is basically the standard benchmark for basically machine learning and deep learning applications. It's the industry standard de facto. We have data analytics also. I'll touch that very briefly at the end. So 20x, as well as great efficiency. So we can say that now, for example, we have a #1 Grid 500 system, thanks to the efficiency of our acceleration in terms of gigaflops per watt. Next one, please. So again, this reflects on the greatest achievements. The Gordon Bell Prize is, as you know, is devoted to the nice supercomputing applications. It's an application-related kind of prize, and there are several of them. Most of them actually are based on NVIDIA platform, on acceleration. So I don't have time to describe that in detail. The square kilometer array radio telescope is present on the right. There are very nice examples in molecular dynamics, in docking, which is very important to find out new drugs for COVID-19 and so on. So next one, please. So we are really expanding a lot this merge of AI and HPC. So deep learning in particular, this is an example for partial differential equations. It's an effort we have from Nvidia research. It's called SciNet. It's still in early access. You see the link there. So basically, it's a way to apply deep learning with some kind of physical constraints so that you can accelerate dramatically, even many orders of magnitude, the results of complex physics simulation, that, like in this case, Navier-Stokes equations in a high Reynolds number, so it's in a turbulent phase. So next slide, please. So again, to say that AI is really getting traction, it's growing in importance in scientific computing and HPC, and as a consequence, the most important computers coming up on the top 500 list are actually growing as already in exascale if you consider AI performance. Some of the examples in green, of course, are Nvidia powered. Some of them are announced, like the Leonardo supercomputer in Italy at Cineca, thanks to a Euro HPC effort. The others are already installed and available on top 500 list. And this is just to compare this with the traditional HPC full double precision kind of standard applications in HPC. Next one, please. So again, those are some of the most recent examples shown at supercomputing last week. Next one, please. So as a side of another effort around this is of course, the software development especially for scientific computing and HPC. And now we provide a toolkit, a full toolkit called Nvidia Hpc Sdk. It's basically a merge of all the existing, some of the existing tools and others. Probably some of you knows already BGI compilers. BGI compilers is now all integrated into this toolkit, which is, by the way, is free. And it's compatible with basically all the top 500 systems, because it works with x86, with Power and ARM. So it's very, it's even multi-platform. And next one, please. So that you also have all the tools for, of course, debugging and so on, and profiling, which is very important nowadays with this complexity of the hybrid architecture with the CPU and GPU. And just as a summary, you can develop accelerated computations like with the standard Cuda, which is our API. It's 12 years old now, is very established on the right, the Cuda itself. So we have, you can also accelerate through, let's say, the directives, OpenACC directives, or the latest thing we support, thanks to the PGI compilers and Hpc Sdk, is on the left is the fact that now C++ itself, and also Fortran, the newer versions are actually inherently parallel and accelerated. So it will be interesting to have codes fully compatible with fully C++, but still accelerated thanks to our compilers. Next one, please. So in particular for life sciences, HPC effort is very important, and Nvidia went all in, if you like, to fight COVID-19. And so we have several examples around this. The efforts around, for example, the Oxford nanopore technology is very important to accelerate genome sequencing, and this works very well with thanks to GPU acceleration. There are lots of examples in supercomputing used for drug design, to repurpose existing molecules and drugs to actually attack the coronavirus. The coronavirus itself was, the structure of it was found thanks to the acceleration of cryo-EM technology for, for kind of a microscopy, if you like, for structures. And then, of course, medical imaging is very important on that. And we have a very nice example. There are several examples around the world, but there is one with the US and National Institute of Health, together with Nvidia, where they came out with a model recognizing COVID-19 on lung CT scans, and other examples for smart hospitals, thermal, finding, the temperature of people and so on. Next one, please. So again, this is a kind of an elaboration of the previous one related to these different examples which are already described. You see that the acceleration is really orders of magnitude. So things are possible now, which were not possible before. And so we announced recently at GTC in October, we announced this new umbrella framework called Clara Discovery, which includes some of those components, most of those components, as well as, for example, NLP specialized for medical literature. This is called BioMegatron. It's included in this toolkit. It's available in GC repository for free, and you can sift all the scientific literature with thanks to the new deep learning NLP models. Next one, please. So now switching gear towards the more the hardware. We already know that the big data growing explosion, especially in scientific computing. We already mentioned the square kilometer array. We also can mention, for example, on COVID-19 graph analysis or graph analytics of all the metabolic chain or graph around the disease, or for meteo simulation, lots and lots of data for terabytes per day, or huge amount of data to visualize in very tiny, tiny details the complex numerical simulations. And in this, we have a nice video for the Mars landing simulation as a concept. And also another very important point that the deep learning models, the deep neural networks are growing in size hugely. This is on the right is a logarithmic graph. So basically they are doubling in complexity every 3 months, which is really impressive. So we need to keep this pace thanks to NVIDIA acceleration. Next one, please. So we announced this week, last week, sorry, the newest release of NVIDIA A100. Now it's 80 gigabytes of graphical memory. The previous version was 40 gigabytes. So this is exploiting the new generation of HBM2E stacked memory, which is based on the same silicon interposer or together with the GPU at the middle of this photo. So as a consequence, the bandwidth is huge. It's now 2 terabytes per second memory bandwidth, which gives you lots of basically performance together with the raw performance of the CPU, the GPU Cuda cores. Maybe we can go to the next one, please, because I'll explain some of the aspects later, included in the Ampere family, like Tensor Cores and MIG and so on. So as a consequence of real life example, we have enormous performance speedups. Again, thanks to this new throughput and new memory. So for example, on Quantum Espresso now is twice the performance. Big data analytics as well, because you can get all your data basically on the graphical memory. So this is very, very beneficial. AI training for large models also is very beneficial, having larger graphical and fast graphical memory, as well as inference, and also energy efficiency now is larger, 25% more. So next one, please. So we have now the third generation of so-called multi-precision tensor cores. Is the technology we introduced with Volta, but now is really a generational leap thanks to the lots of improvements in terms of half precision, P16 acceleration on tensor cores, but also double precision, which is very important, of course, for traditional HPC. So we have a 2.5x improvement over Volta, just thanks to those tensor cores. And you have an example of some applications here on this graph, up to 5x compared to the previous generation. Next one, please. So Tensor Core is quite complex, but it basically is a matrix kind of native hardware acceleration besides the traditional Cuda cores inside your GPU. And we can accelerate, thanks to this approach, we can accelerate floating point 32 now, thanks to the so-called TensorFlow 32 exponent mantissa internal representation, as well as half precision, as you can see here, which is IEEE, the FP16 IEEE. So basically, there is a nice way to exploit this new hardware for your applications. And all this is implemented into our libraries. So you don't need to go into the low-level CUDA to exploit this acceleration. Next one, please. So structural sparsity is another example, especially for AI. And again, this is hardware accelerated when you have basically matrices where most of the entries are close to zero. Let's say this is very typical for deep learning. Next one, please. Next one. Okay, so as a consequence, again, we have amazing acceleration of more complex models. This is an example for deep learning recommender system for it's a large model, and it's implemented in FP16. And as you can see, with the new A180 gigabytes, you have huge improvement just due to the better bandwidth and memory, and also the new Tensor Core. Next one, please. This is true for HPC application as well. I already touched upon that. Quantum Espresso is an example, 80% more. Next one, please. And again, this is a kind of a range of what you can expect with the A100 over Volta, even with the previous version of 40 gigabytes on a range of typically HPC applications like molecular dynamics, LAMP engineering, and so on. Next one, please. Another aspect I can cover is the fact that Tensor Core typically, as I say, it's a matrix multiplication with a mixed precision or reduced precision and so on. So people in numerical simulation are kind of thinking about how to exploit this around the standard simulation models. And there are papers around this concept. Jack Tongara at Tennessee University, the father of HPL, explained this very well. And so, as a consequence, you can not only exploit Tensor Cores just for SP64, but also for with half precision. There are several examples around this in plasma fusion, in weather prediction, and so on. So that's something to think about. Next one, please. Now, this is another very important aspect in the hardware on the Ampere family, on the A100 in particular, is the fact that for the first time, NVIDIA introduced a way to, let's say, partition a physical GPU in a hardware way. So, okay, via software, you have a switch on software, but then the physical GPU is actually fully partitioned up to 7 instances or slices. This can be done very flexibly. And so as a consequence, you can exploit a very powerful GPU like A100 with maybe a mixed workload with some of those low workloads or jobs or applications are less demanding. Maybe some of them are interactive. Think about a Jupyter Notebook, for example, interactively used by data scientists. Think about smaller jobs for just testing. And so you can do that with multiple instances which are fault isolated, and also in terms of memory, but still you have the same physical GPU. And this is totally different from the other technology we have, which is the virtual GPU, which was explained by Clements, which is still present, but this is yet another way to exploit GPUs. Again, on the A100. Next one, please. And so A100, you can have it on multiple platforms, on several OEM vendors, and also on cloud. There are several form factors. starting from the standard PCI Express, which is not shown here, or you can have a 4-way or on an 8-way kind of GPU board, a special board with NVLink and NVSwitch, which is a GPU to GPU communication to have better scalability for multi-GPU. And so you have it with the full stack, of course. You can have it on in multiple ways through OEMs. Next one, please. A40, sorry, is the new announcement on the Ampere family. This is more geared towards, it's still Ampere GPU architecture like A100, but it's more geared towards a mixed kind of applications, including graphics, which is not present on the A100. So you have, for example, you know, real-time ray tracing kind of hardware acceleration here. You have a GDDR memory, 48 GB, which is a lot for a card like this. It's a PCI Express card, by the way, PCI Express Generation 4. And you have also some, even it's a card for servers, you also have some display ports available. So it's very flexible in terms of applications, including, you know, again, compute, single precision compute, but also and virtualization and graphics. High-end graphics, I would say. Next one, please. So the full family, as of now, of NVIDIA data center GPUs for servers and supercomputing is the following. So starting from the smaller T4 up to the A180 GB. Clearly, you can expect, we cannot think, we cannot announce, of course, but you can expect in the next year, next months, you will have other examples of Ampere architecture GPUs coming next year. Next one, please. Is an interesting fact that you can exploit GPUs in many ways. So we explained that we will explain better the supercomputers, DGX systems, and so on. But you can also exploit powerful professional GPU computing through professional workstations. We call them NVIDIA data science workstations, and they are equipped with Quadro RTX professional cards with all the software stack you expect, for example, from NGC repository. So you have a productivity for your basically your department at a workstation office level. Next one, please. So now let's talk about the Bjx family, which is basically an NVIDIA branded kind of family of systems. It's a long story. It's a 4 years now of story. Bjx1 was already explained by Clements in some of our customers, and Bjx Station, and then now we have the Bjx A100. Next one, please. So the Bjx A100 now was recently announced at Supercomputing with the new A100 80 GB GPU card, system module. So that now we have a full 8-way A100 system comprising 640 GB of graphical memory. So this is a huge system for large AI workloads. It's a kind of an appliance thanks to the software coming fully integrated with the system, huge performance, and maybe the graphs on top are a little bit small, but basically it exploits in full the power of the new GPU and also the power of the architecture. Next one, please, which is basically based on 8-way all-to-all connectivity among GPUs, thanks to the latest NVLink and NVSwitch, which is our dedicated fabric for GPU to GPU communication or memory transfer. As a consequence, your large multi-GPU jobs like deep learning training and numerical simulations or data analytics, those things are really, really scalable and accelerated. So the system, of course, is a dual x86 system comprising the latest AMD generation 2 ROM chips with lots of cores and lots of system memory, by the way, 1 TB, 2 TB now. So next one, please. nice thing is that you can use MIG mode, the multi-instance GPU compatibility of A100, so that you can partition the system very flexibly, thanks to the container approach and the MIG technology. So you can have lots of instances at the same time, running at the same time on the powerful system. So you can basically exploit with multiple users and multiple jobs. Next one, please. A very important aspect of this system is the I/O connectivity. We have this is really huge for this system, and so thanks to that, thanks to the Nvidia Mellanox technology, we can build larger clusters, or like our DGX pod and SuperPod. So as you can see, you have 8 ConnectX generation 6, so it's HDR InfiniBand 200 GB and Ethernet. So we have 8 ports like this, plus 2+2 dual, so 2 dual ports for general purpose and storage connectivity. So this is a huge system also in terms of I/O. Next one, please. So as a consequence, you can build up in a modular fashion, you can build up clusters of that. We call those things DGX pod, and we have nice, let's say, alliances with the most of all the storage vendors with the flash storage technology, so that you can build up a full compute and storage solution around this with reference architectures. So you don't start from scratch, you have everything validated. Next one, please. Not only that, but we in-house, we have a long history of building up clusters of such DGX systems. We have now the Selene system with the latest DGX A100 with more memory, as I explained. And so as a consequence, now our internal supercomputer is now number 5 on the top 500 list, announced last week. Is the number 1 on MLPerf, I already explained. It's the number 1 industrial system worldwide. And it also, a portion of it is also number 1 on the Green 500 for efficiency. So, and the nice thing is that it's so modular that we are able to build up this in 3 weeks on the nice data center we have in California. Next one, please. And not only that, but now, thanks to this experience we have, thanks to our partners also in Europe, we are able to offer this as a solution. We call that DGX SuperPod. So we are talking about 20 DGX A100 upwards, including, of course, Nvidia Mellanox networking. Go ahead, please. Next one. So not only that, but we also announced at supercomputing, we announced the DGX station. I see that unfortunately we are running out of time, so I'll explain that now. Next one, please. We introduced the latest A100 4-way into a workstation for the office, thanks to the liquid cooling. So this is a nice new possibility for departments. Next one, please. Next one. We don't have time to explain. Of course, with the MIG mode, you can partition this in multiple researchers. Next one, please. And of course, thanks to the software, it's the same as the larger application, larger clusters. You have the same software. You can switch easily. Next one, please. So I think we are running out of time, right? We have just 5 minutes more. I hope so. So for AI in particular, now it's especially for training now, AI, Nvidia AI is a standard de facto for training, available everywhere for training, but also for inference. Next one, please. I'll explain a little bit very quickly the fact that we have lots of tools available on NGC repository. So that for example, you have lots of pre-trained models thanks to the Nvidia efforts with our supercomputers now, so that you can use those models for transfer learning, and you have a tool for that. And then you can apply that for inference, thanks to our other tools we have, TensorRT and Inference Server. Next one, please. So this is another way to look at that. You can, in order to build up inference applications, you have all the pipeline accelerated with NVIDIA tools, which, by the way, are all free. Next one. So not only that, but we also have SDKs for specific areas. So, you know, conversational AI, recommended system, smart cities, and video analytics a lot, we call Metropolis, but also healthcare. So if you are a healthcare researcher, please come to us. We'll explain you the full Clara healthcare SDK, which is quite, you know, variety. There are lots of tools around that for medical imaging and drug design and etc. So next one, please. Robotics, for example, also we have a nice SDK. Data analytics also, we are now accelerating that in the Python ecosystem. We call that rapids.ai. It's an open source effort. So machine learning, traditional machine learning, data analytics, ETL, also Spark now, version 3 is now accelerated. And we have a large, you know, ecosystem of partners around this, as you can see on the right. And next one, please. And researchers are doing this on, for example, for spatial data, geodata, and we have amazing order of magnitude acceleration around that. So if you are active researchers around geospatial research, please come to us and we can talk about that. Next one, please. So NGC again was mentioned many times. So it's a catalog of containers and models and SDKs. If you are Bjx customer, you can also have a private registry for your own containers. And by the way, it's compatible with all the cloud service provider. Next one. So that's another way to look at that. We are lots of, by the way, we are not only the deep learning frameworks like PyTorch and TensorFlow and the others monthly updated by Nvidia, and with all the examples and pre-trained models and so on, but also lots of open source HPC research applications as well, already under a container. Again, next one, please. Same story, so we can skip that. Again, the container approach gives you a nice way to encapsulate your applications on all the software stack with all the compatibilities, as well as playing well with the Kubernetes approach in order to mix and match different workloads and different applications on the same infrastructure, even the same system. Next one, please. Next one, we can skip that. And so again, this is also available on CSP, major CSP like Azure, Google Cloud, and AWS. With that, next one, I think, so please use NGC. It's a nice, huge effort by Nvidia. You can exploit that for free. So with that, I think I completed with some takeaways. And sorry about being a little bit length. So Nvidia accelerates all the four software stack. HPC is now basically embracing NGC technologies. Ampere family is bringing breakthrough innovations. If you want to have AI and HPC at scale, you can use DGX approach with the pod and superpod. You have NVIDIA AI full stack for your applications, and please use NGC in order to exploit the NVIDIA platform at its best. And thanks for your attention. And again, sorry to be a little bit lengthier. Maybe we have some questions.
Hi.
Hello.
Hello. It takes time to write, so
Yeah, sorry.
Okay. I have I think 3 questions. The first is I saw in one of the slides 1,000 times speed up with respect CPU. Although I have an explanation, I'd like to hear from you. Looking in the specs, one expects something less. How you explain this extremely high speed up? This is common with older versions of GPUs and so on.
Yeah, maybe I have a technical way to explain this. So basically, there are several reasons why. So some of the aspects are the following. First of all, GPUs are, they have thousands of cores, very simple cores, but still there are lots of cores. So that is totally different from CPUs, of course, as you know. So it's a many core approach. So inherently parallel, because of course they start from graphics, and graphics you need to, to feed millions of pixels on the same time on a frame buffer. Okay. And the other reason, the other aspect is that you have millions of threads coming up at the same time. This is also another aspect which is inherently massively parallel. And last but not least, the graphical memory is much faster than CPU system memory. And so you have an inherently massively parallel architecture, which gives you, when the application is actually able to exploit this, you can exploit in order of magnitude. You have really order of magnitude acceleration. Clearly, on the real world, many applications are they have some serial parts or sequential parts and so on. So you have at the end of the day you have some kind of Amdahl limit, but you still have for real life codes you may have 10x or 3x or even 3x, which is typical, and it's a huge benefit. Which, by the way, also on the total cost of ownership, if one may argue, okay, GPUs are expensive, okay, but if you look at the TCO, you have an order of magnitude acceleration, you have a little bit more cost, but at the end of the day, your TCO is better, okay?
Yeah, I think that there's another reason for this non-expected speed up, the very bad performance on CPUs, because you usually you have your old code, you never touch it, you don't invest to speed up. GROMACS is one of the codes that you cannot see this type of speed up because of CPU acceleration. They use
yeah, because you have a mix, right? It's because the full code is hybrid. Of course, not all the kernels are optimized. Even though we are working a lot with GROMACS developers, so it's improving over time. So
yes,
yeah,
I'm aware about this.
The
question is the speed up of 40 gigabytes versus 80 gigabytes A100.
Yeah.
I saw somewhere 3 times speed up.
Yeah.
How you explain? I guess is the 40 gigabytes are used with less efficiency. I guess.
Well,
I don't know.
Yeah.
Otherwise, they should be the same, I guess.
Yeah, I mean, there are several reasons why. Of course, you can argue that you might argue that we selected the nice examples. Okay, that's reasonable, but this is a technological reason around this. There are several ways. First of all, the memory itself is not only larger but faster. Okay, so now it's 2 terabytes per second compared to 1.5, I think, or something like that. So when you have a memory bound kind of applications, you feel the difference. Okay. Now 3x is really huge. Why? Because in that case you have so large a model that you can fit this model on this 80 gigabyte memory entirely. Because of course, when you have 40 gigabyte, in some cases you have a large data analytics example or a large deep neural network, you need to use multiple GPUs. Okay. Now, if you have a larger memory, you can use even one GPU only, and this is much faster than using multiple. Okay, so you don't need to go back and forth with the system memory and so on. So
so these 80 gigabytes are well designed for memory-bound applications.
Well, in general, but of course, better. Yes, of course, better. Yes. Yeah.
The third question is regarding containers. I had an experience 1 year now on multiple machines and GPUs and so on. And okay, containers is the easy way to start running your application, whatever it is, without trying to compile all these special AI packages. What about performance of containers with some applications, say AI, with respect the native build on the machine, take into account hardware specific factors like instruction sets, what GPU, avoid to build all available SMs and so on.
Yeah, I can explain.
Just for one SM.
Yeah. So I can explain. Let me tell you that our records for MLPerf were done with our containers. So there is basically no difference between base OS and containers, thanks to our NVIDIA Docker runtime. So basically, as you know, the containers are running on the same kernel below the scenes. It's a kind of okay, I'm not an expert really on Linux specifics, but it's a kind of you know, let's call it a trick, if you like, okay? In order to, so that basically you are still running on the same kernel, but in an isolated fashion in terms of user space. So really, there are no real differences even on the ISA. So you can use the full GPU. When you assign a GPU, a full GPU, by the way, to the or maybe a MIG instance to the specific container, that container runs the GPU in full, and including all the CUDA low-level details regarding maybe Tensor Core, maybe other stuff related to the GPU. So really, there is no real practical difference, and we use that even on our records. And so that's, I think, it's a nice way to look at that.
This suppose that the container was built for CPU part on the similar hardware. If you have a new CPU with new features, probably you omit the latest features. So you lose a factor of 1 to 1.5 to from this.
Yeah. Yeah. So clearly, okay. There are several ways to look at that. You are right. If you want to have the latest and greatest technologies and latest features on the latest GPU, definitely you need the latest compiler. And so you need to build up basically compile the container software stack on the latest compiler in order to have the latest architectural benefits. That's for sure. Having said that, there are several features in order to help on that, including, for example, Cuda Compatibility mode, which is now available. You can switch between devices, even running on the different, you can run different containers with different devices easily. And so clearly, older containers can still run on the latest GPU, but clearly not, as you mentioned, it's not always true that they will not use the latest features or the CUDA, the GPU architectural benefits. Definitely, that's true. But again, I would say that it's clearly it's not magic. You can think, you need to consider that for sure. But there is still a nice compatibility path, I would say.
Yes. And the last quick question about Nvidia Hpc. The PGI community versions were valid. They had a license for 1 year. The same applies for Nvidia Hpc, or it is free? It will work after 2 years, for example. And thank you with this.
Yes, HPC SDK you mentioned, right?
Yes.
The latest version of PGI compilers. As far as I understand, they are for free. For sure, they are for free for education market. To be honest with you, I need to double check regarding the enterprise market, but I would tend to say that now everything is free. But for sure, for you as a researcher, I think it's not a problem.
Yes, PGI compilers were also free, but they had a license somehow inside, valid for 1 year. So the 1910, the last community PGI edition, now is expired. So
I see.
If the same applies for Nvidia Hpc.
Please contact us, so we'll come up with the for the answer for sure. Because to be honest, we do. On top of my mind, I'm not sure now.
Okay, I can check it. Okay, thank you.
Thank you. Thanks a lot. I see another question. I've noticed that DGX systems natively run on Ubuntu, but yes, exactly. You can have a CentOS or Red Hat if you like. Red Hat is validated on, but also CentOS at the end of the day, because there is a guideline in order to do this. let's see. The question is whether the ecosystem of tools will still be supported on DGX. Whether we are plans in order to provide support and native images for CentOS. I don't think we have native images for CentOS on our roadmap, as far as I know. But of course, if there is enough demand, we can consider that. So we can come back to you afterwards for that. Regarding supporting all the ecosystem of tools, clearly depends on what you consider support, because DGX systems are supported, including our software. Okay. Clearly, there are things like some kind of CentOS package. We cannot be sure about that, right? So this is not supported as a package, but still the officially we support Red Hat. Okay, so CentOS is kind of a in-between kind of use case. It works for sure, but let's say again, it's a great, if you like, it's kind of a in-between kind of use case. But for sure, for in general, even on the Ubuntu ecosystem, if you have a random Ubuntu package, it's you cannot open this NVIDIA's enterprise support and see what that we can support up to all the software stack we actually develop, including the containers, by the way. So we are sure about the system itself with all the OS running, including Red Hat and CentOS, and all the containers. And then, of course, we can see what we can do in order to help you when you have some kind of external package. Clearly, in that case, it's a little bit more difficult, for you can imagine. The NVIDIA ecosystem of tools, yes, of course. For example, an example is OpenShift, for example. We are partners of Red Hat on that. For another example is Cloudera, for example, in the data analytics area. We are partnering with so if you think about the NVIDIA ecosystem of tools, yeah, for sure.
Okay, there is no other question in the chat. I don't know if...
Yes, we have a few minutes for a couple of quick questions. If someone needs to ask something. Okay, I think that everybody is covered for the time being. Just to let you know that you can reach me directly or my colleagues in NVIDIA for any questions that you might have, or for further information. We are at your disposal anytime. Thank you, everybody, for joining us today. Thank you, Matthew, Carlo, Clemens. Your help is always appreciated.
Ευχαριστούμε πάρα πολύ όλους που συμμετείχαν στο webinar. Θέλω να σας ενημερώσω ότι μέσα στην ημέρα θα λάβετε και το link από την παρουσίαση, ώστε όποιοι θέλετε να μπορέσετε να το δείτε. Thank you everyone very much for your attention here, your attendance. Have a nice day.
Thank you.
Thank you. Stay safe, everybody. Bye-bye.
Bye.
Bye.
Bye.